The retina, the most beautiful structure of the eye, it is the nervous layer of the eye, that is, it is the heart and soul of the eye. So, the peripheral retina that you are seeing over here, this line, ridge like structure over here, that is called as ora serrata. The peripheral retina is called as ora serrata, that is attached to the ciliary body, okay, where ciliary body and choroid meet, that is the location where this ora serrata is attached to it. So now when I instill pilocarpine into my patient's eye, there occurs a contraction of the pupil and this pulls off the ciliary body. This causes a contraction of the ciliary body as well. And in some unfortunate cases, when this contracts, the retina detaches from its attachment at the ora serrata. So this can lead to sometimes a retinal detachment. This is a very rare occurrence. Pilocarpine in this way causes a retinal detachment. Okay, that was about the peripheral retina. Now we will see what the central retina is made up of. The center of the retina is occupied by macula. Okay, this region is macula. Okay, all of this, and the center of macula is our fovea. This fovea is the most sensitive to light in the entire eye. The fovea is the most sensitive part to the light. Now, next to this macula and fovea, we have our optic disc. What is the optic disc? This yellow color structure that you are seeing over here is the optic disc, and this green circle marks our macula and black circle is our fovea. Okay. Now the optic disc is the beginning of the optic nerve. Okay, this is where the optic nerve begins. That's the only part of the optic nerve that is visual to us in the fundoscopy. And then the diameter of the optic disc is 1.5 millimeters. It's very important for you to remember this. You are asked frequently. Then the fovea also is 1.5 millimeters. So both fovea and the optic disc measure about 1.5 millimeters, and the distance between these two, that is the optic disc and the fovea, is 3 to 4 millimeters. Okay, the distance between optic disc and fovea is 3 to 4 millimeters. Let's get into some complicated details of retina. It in total has 8 types of cells in it. Okay. 5 types are neurons and 3 types are the accessory cells, that are our neuroglia. Okay. Now let's look at the 5 types of neurons. These are the photoreceptors, that is the rods and cones, the bipolar cells, the ganglion cells, the Amarcine cells, and the horizontal cells. These are the 5 types of neurons present in retina. The photoreceptors are the first order. These are very frequently asked. Please memorize this. The first order is our rods and cones. That's the photoreceptor. Bipolar, bi means 2, right? So these are the second order neurons. That's how you can easily remember. Bi means 2. So they are the second order neurons, and ganglion cells are the third order neurons of the visual pathway. The other 2 types are the Amarcine cells and the horizontal cells. Let's study these rods and cones in detail. This is your fundus with its distribution of rods and cones. You can see the cones are concentrated more in the center. All these colored dots are our cones and our white colored dots are rods. So rods are peripherally located and cones are centrally located. Now come to the number. You can see from the picture also the rods are very much high in number compared to the cones. That's almost 20 times the number of cones. Rods are 120 million in number and cones are only 6 million in number. There is only one type of rods. However, there are 3 types of cones depending on the color sensation that they get. Red cones, green cones and blue cones. You can remember from the image also. There are red cones, green cones and blue cones. However, the rods are only of one type. Now coming to the function, the rods are responsible for the peripheral vision, the black and white vision and the night vision. Okay. They are concerned with peripheral vision, black and white vision and the night vision. Now the cones are exactly opposite to this. Now the peripheral becomes central in cones, black and white becomes color and night becomes your daylight vision. Okay. So that is about the differences between rods and cones. Let's look at what happens when there is a problem with the rods and cones. This condition is called as color blindness and is called so after the name of the scientist who discovered this, and he published a paper, first paper on color blindness, that is Dalton. His name is Dalton and we will call it Daltonism. Okay. Are you all able to see this number 3? If yes, then congratulations, you do not have color blindness. Okay. So what we know is that color blindness is quantified with the help of Ishihara's chart. This image is an example of what kind of plates are present in the Ishihara's chart. You are going to ask the patient what he is looking at. Now, depending on the number of colors that a person can see, a normal person we call a trichromat, where all 3 types of cones are functioning normally. Then dichromats, only 2 types of cones are functional. Now, in red color blind people, it's obvious that the red cones are absent. So, in green and blue, the green and blue cones are absent respectively. In whatever color blindness, that colored cones are absent. Please remember this. And now, monochromats means there is only one type of cones. And what is the most common type of color blindness? This can be a question. 90% of people are red-green colorblind. That is, they can only see hues of